Here's how to figure out the voltage drop for a parallel run of conductors. The formula you'll use is voltage drop equals current times distance times resistance divided by the number of parallel conductors. Let's break down each part of that formula. First, current. This is the amperage flowing through the conductors. Second, distance. This is the length of the parallel run in feet. Third, resistance. This is the resistance of the conductor per unit length, typically expressed in ohms per 1000 feet. Finally, the number of parallel conductors is simply the number of conductors running in parallel to carry the load. To determine the resistance of a conductor, you'll typically consult a table. For example, the resistance of 500.0 mcm copper wire per 1000 feet at 75 degrees Celsius is approximately 0.501 ohms. Now, let's apply the formula with an example. Assume you have a current of 200 amps, a distance of 624 feet, and two parallel conductors. The voltage drop calculation would be voltage drop equals 200 amps times 624 feet times 0.501 ohms divided by 2. This simplifies to voltage drop equals 6,266.88 divided by 2, which further simplifies to a voltage drop of 3,133.44 volts. Please note that this calculation provides an example and assumes constant parameters which may vary. Always consult the National Electric Code and engineering resources for accurate values and safety standards for specific installations.